Hello students, and welcome to the third in our series of videos on Taylor polynomials in series. And in the last video we talked about our first attempt here at finding a Taylor polynomial to estimate sine of x using pi over 6 as our sort of special point there. Okay. And it worked great for a while until here when we try to take the first derivative. So let's improve on that method and let's try our second attempt here. And I've just written down some helpful reminders here on the side. Remember, the function f of x that we're using here is sine of x. Our special point is pi over 6. And then I've taken a bunch of derivatives of the function just to kind of speed up the process here. So now let's try g of x equals to f of a, and I'm writing this out in general terms, and then I'll fill in the details in a minute, plus f prime of a times x minus a. Okay. Bearing in mind that a is pi over 6. So we're going to make this attempt now. So that means g of x is equal to f of a, which is sine of pi over 6, or 1/2, plus f prime of a, so that's cosine of pi over 6, root 3 over 2 times x minus a, which is pi over 6. Okay. And at this point, I have to point out here that, the first mathematicians who figured out this problem took them a little bit more time in thinking, and I'm giving you sort of a speed up or a hurry up version of this. But I hope to illustrate to you that in our examples why this second part here was so important and useful. So let's check now. Okay. So remember our checks. We want to see g of a versus f of a. Okay. So g of a, or I'm just going to put in directly pi over 6 here, since that's our special point. Okay. G of pi over 6. And f of pi over 6. Well, f of pi over 6 is easy. It's just sine of pi over 6, so that's 1/2. G of pi over 6 is 1/2 plus root 3 over 2 x minus, or x here is pi over 6 minus pi over 6. So this part here is gone. It's 0. So g of pi over 6 is 1/2, which does in fact equal f of pi over 6. So we're happy there. Let's keep going now. I mean, we got to this point last time. Let's check our first derivative. Well, g prime of x, using what we have up here, derivative of 1/2 is 0. The derivative of this part is root 3 over 2. Okay. So now let's check g prime of pi over 6. Well, this is a constant, so it's still root 3 over 2. F prime of pi over 6, that's cosine of pi over 6, so that's equal to root 3 over 2. So these are in fact equal, and we are happy again. Okay. Well, let's keep going. Let's try the second derivative. G double prime of x, keeping in mind that g prime of x is now a constant, so g double prime of x is equal to 0. G double prime of pi over 6 is also equal to 0. F double prime of pi over 6 is equal to negative sine of pi over 6, which is negative 1/2, which is not equal to g double prime at pi over 6. So at this time now it's failed. Okay. So in our first attempt, we made it past the first point, but we failed at the first derivative. Here we succeeded at the original equation, succeeded at the first derivative, but failed at the second derivative. So now we're going to try again. Okay, and in this process too, hopefully you can see that good mathematics, great useful mathematics comes with a bit of sweat and elbow grease here. So, and if you can kind of notice this process here, this x minus a, this is necessary because for the first time that you make a substitution of a in here, you want this part to go away so that you're just left with f of a. Then when you take the derivative, the constants here disappear and you're left with the f prime of a. Okay? So in our third attempt, we are going to say that g of x is equal to f of a. So we're going to take exactly what we had last time, because it works so well for the original equation and the derivative. But then we're going to add on this part, f double prime of a times x minus a squared divided by 2. Okay. And so this is a bit of a mystery as to why how this came about, but I will run some examples here so that you can see why this divided by 1/2 and this squared here is necessary. So that means when we first check, let me rewrite this using the specific values that we have. So let's see, g of x then is equal to f of a, which is 1/2, plus f prime of a, which is root 3 over 2, times x minus pi over 6, okay, plus f double prime of a, which is this guy, which is negative sine of pi over 2, so that's 1/2, negative 1/2 rather, divided by 2, or that's 1/4, times x minus pi over 6 squared. Okay. So let's see why this works. Let's switch up the colors a little bit here. So let's check now. G of pi over 6. So you can see that we get 1/2. We plug pi over 6 into here, so that's 0. And we plug pi over 6 into here, that's also 0. F of pi over 6, we already know, is 1/2 from up here. So that works. Done. No surprise there. Now let's see what happens. G prime of x. So this 1/2 here goes away. And this part here, we're left with root 3 over 2. And then minus. And here's why the square is necessary. So if we take this derivative, then we get 2 times that. So that's negative 1/2. And then times this whole thing, okay, times the derivative of the inside, which is just 1. Now you can kind of see here that if we hadn't divided by 1/2, this would now be 1. Okay, and that's going to lead us to some problems later on. So let's check. So let's keep going with our check. G prime of pi over 6. Well, when you put pi over 6 into here, that's all gone. So you're just going to have root 3 over 2. Now, what's f prime of pi over 6? It's root 3 over 2. Okay, so this also works. Okay, so this is the first derivative here. And then let's check the second derivative now. So g double prime of x is the derivative of this portion right here. That's 0. And this is just negative 1/2. Okay. F double prime of... Sorry. So at this point we have g double prime of x is just negative 1/2. G double prime of pi over 6 is, well, negative 1/2 as well, because it's a constant. F double prime of... Sorry, I wrote double prime up here. I don't know why I did that. It should have just been prime. F double prime of pi over 6 here is also equal to negative 1/2. So this is also equal, and we've made it to our to an improvement. Okay, and you can see that this division by 2 here is absolutely necessary. Otherwise, we would have had a negative 1 here instead of a negative 1/2, and a negative 1 here instead of a negative 1/2, and it would not have passed the second derivative. this square here is also necessary, otherwise we would not have this part here to take the derivative of for our second derivative. And I think we can continue here, and it would be no surprise to you that it's the third derivative is going to fail. So g triple prime, or the third derivative of x, is going to equal to 0. G, the third derivative of x at pi over 6, is also going to equal 0. The third derivative at pi over 6 is equal to 0. Now the third derivative of f at pi over 6 is negative cosine of x, so that's negative cosine of pi over 6, or negative root 3 over 2, so this is now going to fail at the third derivative level. But rest assured, we know how to resolve this problem. And the idea is we're just going to add another term to the end here. Okay? So hopefully at this point you get the general approach and the general idea on how to create a polynomial that approximates sine of pi over 6, or really the sine function in general. I will end this video here and pick it up on the next page.